నమస్తే మై డియర్ స్టూడెంట్స్, నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్. డైరెక్టర్ జేసీ సార్ ఆధ్వర్యంలో శశికాంత్ వాల్మీకి సార్ పర్యవేక్షణలు నిర్వహిస్తున్న సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఈసెట్ 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో, ఎవరైతే క్వశ్చన్స్కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ని ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేస్తుంది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారనే ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్స్ మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
Students, we are discussing here AP Ecet Electronics and Communication EDC questions. First, question number 101. A P-type semiconductor carries net. Option 1 positively charged, option 2 negatively charged, option 3 uncharged, option 4 charged at a higher temperature. Actually, in P-type semiconductor, majority charge carriers are holes. Holes consist positive charge, and minority charge carriers are electrons. Electrons consist negative charge. But when they are mentioned, the net means, remember, it is uncharged. What is the answer here? Uncharged is the correct answer. Next question. The intrinsic carrier concentration the intrinsic carrier concentration of silicon sample at 300 K is 1.5 into 10 power 16. So, what is the Ni value here? 1.5 into 10 power 16 per meter cube. This is intrinsic semiconductor concentration. If after doping the number of majority charge carriers are 5 into 10 power 20 per meter cube, then the minority charge carrier density is asking. So, I am considering it is N type semiconductor or P type semiconductor, whatever it may be. We know that electron, according to mass action law, N into P is equals to Ni square. N into P equal to Ni square. Here what is an electron? P means what? Holes. Electron concentration, hole concentration. I am considering here majority charge carriers. Are electrons. So, N equal to how much? 5 into 10 power 20 per meter cube. Then by using this mass action law, N into P equal to Ni square, I am calculating, see here, P equal to Ni square by N. Ni square by N, that equal to, I am writing Ni square means 1.5 into 1.5, 10 power 16 whole square, that is 10 power 32 divided by N value how much? 5 into 10 power 20. 5 into 10 power 20. 5 1 ja 5.3, 1.5. So, if I multiply 1.5 into 0.3, that is 0.45. 0.45 into 10 power 12, that I am writing as 4.5 into 10 power 11. 4.5 into 10 power 11, what is the units? Per meter cube. Hence, option 1 is the correct answer. Intrinsic carrier concentration is given and majority charge carrier concentration is given, then is asking minority charge carrier concentration. So, what is the answer? 4.5 into 10 power 11 per meter cube, and it can be determined by using mass action law. Next question number 103. The ratio of mobility to the diffusion current in a semiconductor. Here, according to Einstein relation, the ratio of diffusion constant to mobility constant dP by mu p, that equals to dN by mu n. Diffusion constant of electrons to mobility is equals to a constant Vt. This is Einstein equation. dP by mu p equal to dN by mu n equal to Vt. Here I am considering dP by mu p is equal to what? Vt, and Vt equal to kT by Q. Units are volts. What are the units? Volts. This is diffusion to mobility, but is asking here mobility to diffusion. Reverse is asking. So, units are, if it is mobility to diffusion, the units are per volt, voltage power -1. So, option 1 is the correct answer. Per volts is the answer. Next question. A half-wave rectifier, question number 104. A half-wave rectifier uses a diode with forward resistance Rf. The voltage is Vm sin omega t and the load resistance is RL. Then the DC current is. So, actually DC current in half-wave rectifier formula IDC equal to Im by pi, but in options Im is not given. See, all answers in terms of Vm only. So, here what is Im means? Im equal to formula Vm by Rf plus RL. Vm by Rf plus RL. What is Rf? Forward resistance. RL is load resistance. Vm maximum voltage. I am substituting here. Then DC current IDC equal to, in half-wave rectifier I am writing Vm by pi into RF plus RL. RF plus RL. This is the answer. Vm by pi into RF plus RL. So what is the correct answer here? Option 2 is the correct answer. Next question. Question number 105. Which among the following is a frequency control device? MOSFET, quartz oscillator, IGBT and BJT. So here out of these 4 devices, frequency control device is what? Means quartz oscillator. Remaining devices are transistors, some devices are voltage control devices, some devices are current control devices, but frequency control device is what? Quartz oscillator. Next question. Question number 106. Which type of special purpose diode is formed by a metal and semiconductor? See here, varactor diode is also a combination of p-n junction diode, varactor diode. Tunnel diode is also a combination of p-n junction diode. Zener diode is also a combination of p-n junction diode. But here Schottky diode, see here, Schottky diode, this is the symbol. Schottky diode is a combination of metal and n-type semiconductor. Combination of, one is what? This is metal, and what is this? N-type semiconductor. Metal and n-type semiconductor. What is the device name? Schottky diode. It is especially this type of device is used in switching application, fastest switching application. We are using this device, and Schottky diode, you remember, it is a combination of metal and n-type semiconductor. Next question. Next question 107. A differential amplifier has a differential gain of 20,000 and CMRR is 80 decibel. Then the common mode gain is given by. Here common mode rejection ratio CMRR is given in decibel. So I am writing formula CMRR in decibel. CMRR in decibel, I am writing formula that equals to 20 log AD by AC, 20 log AD by AC base 10. This is the formula. CMRR in decibel equals to, what is the formula? 20 log AD by AC base 10. So see here, CMRR value is given as how much? 80 decibel. 80 is equals to 20 log AD, differential mode gain is given as 20,000. AC we want to calculate now, base 10. So 80 by 20, next step I am writing 80 by 20 means how much? 4. 21 ja 20, 24 ja 80. So 4 is equals to log of 20,000 divided by AC base 10. Here onwards I am writing 20,000 divided by AC equal to 10 power 4. Therefore AC common mode gain is equals to 20,000 divided by 10,000. 20,000 divided by 10,000. So what is the answer? Common mode gain value is 2. What is the value? Common mode gain value is 2. Option 1 is correct. This is question number 107. Next question, question number 108. This is instrumentation amplifier question. See, here is a big question. Actually, I am considering this question plus minus. This is the circuit diagram is given 20K. Here also this is given. This is the circuit diagram given. What is this value? V1, this is V2, this is V01, this is V02. And what is this value? This is 20K, this is also 20K, and this is 10K. Now is asking V01 minus V02. What is asking? V01 minus V02 is asking, equal to dash. See here. Here actually if you write some KCL equations here and here, you obtain two equations. I am writing the two equations. What is the equation means? According to offset voltage, this is V1, this is V2. Right. V1 minus V01 divided by 20K plus V1 minus V2 by 10K is equals to 0. This is equation 1. Similarly, V2 minus V02 divided by 20K plus V2 minus V1 divided by 10K is equals to 0. By using these two equations, if you find V01 minus V02, V01 minus V02, you will get 5 into V1 minus V2. See here, V1 by 21K, V1 by 10 minus V2 by 10K. Here also you will get V2 by 20K, V2 by 10K minus V1 by 10K. You will get V01 value something, V02 value something, then V01 minus V02, you will get 5 into V1 minus V2. Option 3 is correct answer. Next question. Question number 109. Transconductance. Transconductance means, see here, transferring conductance. So here transconductance means input voltage to output current. Input voltage to output current. Then GM, transconductance, we studied in field effect transistor. What is that formula? Delta ID by delta VGS. Delta ID by delta VGS. What is ID? Drain current. VGS is gate voltage. Here drain current is what? Output current. Drain current is output current. And delta VGS, what is VGS here? Input voltage. Input voltage. Now what is the question here? Transconductance in a field effect transistor. That's why I mentioned in field effect transistor. How effectively the input voltage controls what? Answer, output current. Because transconductance GM equals to delta ID by delta VGS. ID means what? Drain current. VGS means what? Gate voltage. In field effect transistor, drain current is output current and gate voltage is input voltage. So we know that FET is a voltage control device. Here input voltage controls output current, or the output current is controlled by its input voltage. Next question. Question number 110. Which of the following is true? A silicon wafer heavily doped with boron is a P plus substrate. A silicon wafer lightly doped with boron is a P plus substrate. A silicon wafer doped with arsenic. So here very important point, first P plus. What is the difference? P means lightly doped semiconductor. P plus means heavily doped semiconductor. First P plus means what? Heavily doped. So in our 4 options, you first check it where it is heavily, right. And second point is a p-type semiconductor will be obtained by adding what type of impurities? Trivalent impurities. Trivalent impurities means which group? Third group. What are third group elements? Boron, aluminum, gallium, indium and thallium. So here a silicon wafer heavily doped with boron. A silicon wafer heavily doped with boron is a P plus substrate. So option 1 is correct. Here also heavily doped but with arsenic. Arsenic means what? It is a pentavalent impurities. So when an intrinsic semiconductor, that means silicon wafer, is doped with arsenic, arsenic means fifth group element, then it is N type, not P type. So here the correct answer is it is heavily doped with boron. Option 1 is correct. Next question, question number 111. The DC current gain of a BJT, beta value is given as 50. Beta value is given as 50. Assume that the emitter injection efficiency, gamma value is given as 0.995. Is asking the base transport factor beta star. Is asking beta star equal to how much? So there is a relation in a field bipolar junction transistor. What is that one means? Alpha equal to gamma beta star. This is the formula. Alpha equal to gamma into beta star. Here is asking beta star, gamma is given but alpha is not given. We know that alpha equal to formula in terms of beta, beta by 1 plus beta, that equal to 50 by 1 plus 50, that equal to 50 by 51. 50 by 51. Now is asking beta star, therefore I am writing here beta star is equals to alpha by gamma. Alpha by gamma. What is alpha here? 50 by 51. 50 by 51 and gamma value is given as 0.995. If you multiply with 51 and dividing, then you will get 0.985 is the answer. What is the answer? 0.985 is the answer. Option 2 is the correct answer. Next question. Group 1 is given BJT, mass capacitor, laser diode, JFET. Group 2 is given as population inversion, pinch off voltage, early effect, flat band voltage. BJT means everyone knows early effect, and laser diode means everyone knows population inverse. JFET means pinch off voltage and mass capacitor means this one. So P, what is the answer? 3, Q, mass capacitor 4, laser diode, population inverse 1, JFET, pinch off voltage. Hence, option 3 is the correct answer. Option 3 is the correct answer. Next question. Again this question is asked. See here. Question number 111, question number 113, both questions same with the same data, same options. Here also the correct answer is what? 0.985. Next question. Question number 114, low input impedance and high output impedance. Low input impedance and high output impedance. So there are 4 amplifiers we discussed in negative feedback amplifier, voltage amplifier. Actually what these 4 are options. Question is not given here. Question is not given here. Question will be there, but the answer is correct. Low input impedance and low output impedance. Question number 114. Yes, actually question is not typed here. A good trans impedance amplifier. A good trans impedance. A good trans impedance amplifier. A good trans impedance amplifier has, this is the question actually, here they are not selected. A good trans impedance means trans resistance amplifier is asking. So there are 4 types of amplifiers: voltage amplifier, trans resistance amplifier, trans conductance amplifier and current amplifier. Voltage series, voltage shunt, current series, current shunt. We discussed 4 types of amplifier. Now is asking trans impedance means what? This is amplifier. Resistance impedance means voltage by current. So here voltage and this is current. Then trans impedance, voltage by current is what? Resistance or impedance. So if it is voltage sampling, voltage. If it is shunt mixing, current. So what type of feedback amplifier? Voltage shunt feedback amplifier. Voltage shunt feedback amplifier. This is voltage shunt feedback amplifier. So in voltage shunt feedback amplifier, input impedance will be less, input impedance decreases, Ri equal to 0, and output impedance is also less, R naught is 0. Ri equal to 0, R naught equal to 0, then it is voltage shunt feedback amplifier. We also derived the equation Zi by 1 plus A beta, Z naught by 1 plus A beta, ZIF, ZOF equals to. Here they asked question, a good trans impedance amplifier has low input impedance and low output impedance. Low input impedance, low output impedance, that means Ri equal to 0 and R naught is also 0.
If a small capacitance is connected in parallel with a large value, the combined capacitance will be. Okay, if you see that especially when two capacitors connected in parallel, what will happen here? Definitely like C1, C2 if you take, this is what parallel. So what will be the equivalent we get? So capacitances get added, right or not, whenever two capacitors connected in parallel. So small value I am considering, suppose C1 I am considering what, 2 farad, and C2 I am considering large value like 10 farad. So what will be the equivalent we get? So 10 plus 2, so it becomes 12 farad. So definitely that will be a what, higher value, that is the what, equivalent capacitance. So higher is the what, right answer here for the question. So next one, if you see here, a capacitor that can store 100 micro coulombs of charge with 10 volts across its plates has a capacitance of, look at here, what is the charge stored by this capacitance? Q is given as what? 100 micro coulombs. And how much voltage is available across this? 10 volts is available across this, right? So we know that relation Q is proportional to V. If you remove this proportionality, we get what? CV. Q is equal to CV. So capacitance C is equal to, we get what? Q by V. So substitute this, C is equal to 100 microcoulombs by the what? 10. So automatically capacitance we get what? 10 microfarad. So 10 microfarad is our answer. Simple. Q is equal to CV concept. So that is the basic rule in our Ohm's law. Next question, if you see, the resistance of a conductor of diameter D and length L is R. If the diameter of the conductor is half and its length is double, then the resistance will be. We know that resistance is represented, R is equal to rho L by A. A is the cross section area, but cross section area I can represent in the form of what? For a circular wire, like I can write 5d square by 4. This will be the what? Area of that. Now the thing is what? Observe here, the length is what becomes L is equal to, L becomes 2L and D becomes what? D by 2. This will be the what thing. Now if you check here, how I can write the new resistance here? Rho into 2L by, look at this, 5 into D by 2 whole square by 4 we get. So now if you simplify here, what will be the result we get? R is equal to 2, if you take it out, rho L by 5, D square by this 4 is present, and here also 4 is there. So that is 1 by 4. If you take into numerator, R is equal to 2 into 4, 8 into rho L by 5d square by 4. So this one is the previous resistance and this is the new resistance. So what is R dash? It becomes what? 8 into R, right? So this will be the what? Correct answer. Simple. R is equal to rho L by A. If you take the resistance of that length L and cross section area of what? A, okay, and having material resistivity rho, then R is equal to rho L by A. So based on this, we identified that new value of resistance will be 8 into R. Next one, if you see here, okay, so an ideal regulated power supply is one which has voltage regulation. What is voltage regulation formula? Voltage regulation formula, if you see, so voltage at no load minus voltage at full load by voltage at what? Full load into 100. If you see that ideal supply, if you take what will happen? This will be the ideal supply, and this is what our, you can treat, you take V no load is equal to full load, we get, there won't be any difference. So because of this, whenever both are equal, then voltage regulation, this will be what? 0%, right? Because no load voltage is equal to full load voltage, so there won't be any percentage regulation you can treat. Next one, if you see here, next question in this.
A PN junction act as everyone knows it is a unidirectional switch, because when it is in forward bias it is act as short circuit. When it is in forward bias it act as short circuit. When it is in reverse bias it act as open circuit. So it act as a unidirectional switch.
What will be the reading of ammeter in the figure, right? Figure given below. If the voltmeter reads what we will say 12 volts. Look at here, this reading is what given 12 volts across these 4 ohms, means what is the current here? Current is nothing but 12 by 4 means 3 ampere. 3 amperes is what entering at this node. So here if you redraw this, entering current at this node is 3 ampere. This branch is what 8 ohm, and another branch is what 3, and look at here, another branch is 3, and in between we have a ammeter like this, 3 and 1. So now if you follow with this, what is the current flowing through this branch? This branch current only will give the what? Ammeter reading, right? So we follow with current division rule. Current division rule we are applying here. So total current, so ammeter reading is nothing but total current 3 into opposite resistance 8 by total resistance 8 plus 3 plus 1. If you simplify here, 3 into 8 by 12. So 3 4s are 4 2s are. So current through the ammeter or ammeter reading is how much here? 2 amperes. Right? Simple concept here. There won't be much difficulty. Just you need to apply the what current division rule in this question. Okay. Next one, if you see,